What up? It's day 4 Advent of Code, and I'm gonna walk through my solution for the day. So let's look at day 4, series search. It tells us one of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the series monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search. She only has to find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though, as you don't merely need to find one instance of Xmas, you need to find all of them. Here are a few ways Xmas might appear, where irrelevant characters have been replaced with dot. So we see it can be diagonal, backwards, upwards, horizontal. The actual word search will be full of letters instead, like this. In the example, it shows up 18 times. Take a look at your input. How many times does Xmas appear? So this is our input. I saved it to my local machine. And so if we say ls or cat input.txt, we can see this is my input right here. So what's our approach? First of all, I'm gonna get the puzzle from the file using open. So this context manager makes it so that F gives us access to our file. And then I'm just gonna take out the whole puzzle. I'm gonna have it as a list of strings. So I'm gonna say for each line, I want the line, but without the new line at the end, right? I only want the letters from each line. So I'm gonna strip the new line. Just like that for each line in our file. And I want a list of all of them. So now if I print the puzzle, we should see that we get a list of each line, and we see that each string doesn't have a new line at the end, which means that it's just what we expect, basically. So now I'm gonna take our puzzle, I'm gonna pass it into our solution for part 1. So now for the approach. So how can we look for Xmas in our puzzle? What we can do is we can look at every position of a letter, and then we can search in every direction for Xmas. And since there's only 8 directions, and Xmas is only 4 letters long, that means we'll only be looking at like 32 places for each letter, which isn't that much. It's a constant amount, and there aren't that many letters. So that's sufficiently fast. So I'm gonna get the dimensions of our puzzle by looking at the lengths, like this. And then I'm gonna iterate through each position. And then we're gonna go through each direction. So there's 2 ways we could do it. We could explicitly say each of the 8 directions, or we could say the X and Y component of each direction. So I'm gonna go with the latter because it's a bit easier to type. You'll see what I mean in a second. I'll say for dx, it represents a small change in X, right? We could either go backwards or vertical or forwards. And same for dy. We could go backwards, horizontal, or forwards. I'm actually saying them backwards, right? But it kind of depends how you think about it. And if dx and dy equals 0, we should continue because that means that we wouldn't move at all, right? And why I named them dx and dy, it's because I'm just gonna assign I and j to x and y so I can just change them directly, right? So for each of these, I'm gonna look at each letter. Right, I'm gonna say for letter in Xmas, and I'm gonna advance it, right? So I'll say if the puzzle at x and y does not equal the letter, well then we should stop looking, so we should break. But if it does, then we should update x with the change in x. So you see why I named it now, right? And we update y. What's going on? And we update y with the change in y. And so now, oh, there should be a in here. Yep, there we go. And so now we see that I named it like that, so that way when we update it, the names coincide. X and change in x, y and change in y. And so if we don't break, we can count one more that we saw. So let's keep track of a total and add one to the total. And at the top, let's make sure we initialize total to 0. And then at the end, we can just say return the total. Wondering what else does here, right? So when in Python, when I do a for loop, if I break, the else condition does not, if I break, then we stop the loop and we move on through the code, right? But if we don't break, then this else condition gets executed. So in this case, the else condition getting executed means we matched every letter of Xmas to our position in the direction we were looking at, right? So to reiterate, we look at each position in our puzzle, and then from that position, we try each of the possible 8 directions and see if we can spell out Xmas. And if we can, we add 1. We should make sure every time we explore a new direction that we reinitialize X and Y to the original position, starting position. Whenever we update our X and Y, we should check that it still remains within the bounds of the puzzle, right? So if X isn't within 0 to M, or Y isn't within 0 to N, then we should break. And if you're wondering why I put the break up here instead of after here, is because we only want to check if it's in bounds if we actually need to access it to compare against the letter, right? But since I do this update at the end, it might be the case that we successfully matched Xmas horizontally, and then we add 1 to Y and it goes out of bounds. But it's fine because we're done with the whole word, but we would have broke and not counted it if we did the check after the X and Y update. So let's try this. Let me get 2543, and we see that was the correct answer for part 1. For part 2, it says we misunderstood the assignment, and when we look at the instructions, we see that it isn't actually an Xmas puzzle, it's an X-Miss puzzle, in which you're supposed to find the 2 miss in the shape of an X. So one way to achieve it would be like this. So basically, if we can have 2 misses form an X, then we count that as 1. And so in this example, that happens 9 times. Here, here, and so on. And so now we're meant to count how many times does Xmas appear. So we can take a similar approach. We can iterate through every position. So let's copy paste our code right here. The difference here is that for each position, instead of searching in each direction, what I'm going to do is I'm just going to check if the center is correct, right? So it's the center A, and then I'll take the other diagonals. So I'll take this element and this element and check that it's either SM or MS. And then same for these two, right? It should be either SM or MS. And since we know this A has to be in the middle, we can sort of start iterating from a more intelligent place and not have to worry about doing this bounds checking, right? So like, for example, I never want to look at an A on the edge because we know it can't be the middle of X. Same for this edge, and this edge. And we know if the A is within the edges, like here, then we'll always be able to look at the diagonal and not have to worry about it being in bounds. So right here, I'm going to make sure that I go from 1 to m minus 1. I'm going to go from 1 to n minus 1. And now I can say if puzzle I, j does not equal a, then we should continue. And then we can take our diagonals. So we should say if puzzle I minus 1, j minus 1, plus puzzle I plus 1, j plus 1 is not in MS or SM, then we should continue. And similarly, we should take the other diagonal, right? So we should say I minus 1, j plus 1, and then I plus 1, j minus 1. Just like that. And if it satisfies all these, then we found an x, right? And so we should count one more. So let's print that out. Oh, make sure we go back up here. And for this line, we print part 2. And we see we get 1930, and that was the correct answer for part 2. So, nice. We got Advent Code Day 4. Thanks for watching. If you want to see daily LeetCode solutions, come join my Discord. I'll make sure to post my solutions for Advent Code on GitHub. And yeah, have a good one.